Graphing absolute value functions. Absolute value is the distance of a number from 0. The absolute value of -3 is 3. The absolute value of 5 is 5. A parent function is the simplest of a particular type of function. The vertex is the maximum or minimum value, so that is the high point or the low point of the graph. The axis of symmetry is the vertical line that acts like a mirror. Slope is the steepness of a line or the rate of change. And a translation is a horizontal or vertical slide. In our first example, we're asked to graph the absolute value parent function. F of x equals the absolute value of x. And we have the beginnings of a table of values where the x's are already pre-established. So we just picked convenient x values that center around 0, just to see what happens. When we substitute -2 in place of x, we have f of -2 equals the absolute value of -2, which is 2. F of -1 is the absolute value of -1, or 1. The value of the function at x equals 0 is 0. The value of the function at x equals 1 is the absolute value of 1, or 1. And f of 2 equals 2. Now we're going to graph these points. We'll notice that we can connect them with 2 straight lines, or rays actually. And the vertex is the minimum point. It's that place where the graph appears to change direction, has coordinates 0, 0. So it'll be nice to see where is it found in the table of values, and where is it found in the equation itself. So these are things that we'll be looking at in this video. Please keep in mind that f of x equals the absolute value of x is called the parent absolute value function. And we're going to be comparing other graphs to this original function. There is a line of symmetry right here, the y-axis. X equals 0 is the axis of symmetry. So now we're going to take another function which is related to this parent function. F of x equals the absolute value of x minus 2. And we're going to substitute our x's into the function and get corresponding y values. So f of -3 is the absolute value of -3, which is 3, minus 2, that's 1. F of -2, the absolute value of -2 is 2. 2 minus 2 is 0. F of -1 is the absolute value of -1, which is 1. 1 minus 2 is -1. And we continue like this. And it looks like as I'm increasing x's by 1, my y is decreasing by 1. But all of a sudden at this point, the y now starts increasing by 1. So it looks like the vertex, the place where the graph will change direction, will be 0, -2. We can see that place in the table as the vertex. And in the equation, x equals 0 would make the expression inside the absolute value bar 0. And then we've shifted 2 units down. So please note that the function f of x equals the absolute value of x minus 2 is a vertical shift 2 units down from the parent function. Next example, f of x equals the absolute value of x plus 3. So here we have an expression inside the absolute value. So we're going to have to do some math before we take the absolute value of the expression. F of -6 equals the absolute value of -6 plus 3. So we think, what is -6 plus 3? That's -3. The absolute value of -3 then would be 3. So -6, 3 lies on this graph. F of -5 is the absolute value of -5 plus 3. That's the absolute value of -2, which equals 2. And we continue, and we notice that there happens to be a pattern here in the table. And remember, when the pattern changes direction, we've identified our vertex. So our vertex, it looks like right now, is at -3, 0. I've used mental math to figure out these y values at each corresponding x value. The graph looks like this. The vertex is definitely -3, 0. We see it in the table of values. We see that this graph is a horizontal shift 3 units to the left of the parent function. And my vertex is there, and at x equals -3, the value inside the absolute value expression is 0. Okay, next example. We have f of x equals the absolute value of x minus 4 plus 1. So this particular function will end up being a shift, I believe, that is 1 up from the parent function, that's the plus 1 outside of the bars, and 4 to the right, because the vertex will be at 4, 1. So that's my prediction. Let's check it by doing some math. I just substituted 1 in place of x. F of 1 is the absolute value of 1 minus 4. That's the absolute value of -3, which is 3. 3 plus 1 is 4. F of 2 equals the absolute value of 2 minus 4. That's the absolute value of -2, which is 2 plus 1 is 3. And we continue like this using mental math to complete our table of values. We plot our points, and we see that indeed the vertex is at 4, 1. We see it there in our table. Remember that the x value of the vertex will be the value of the function that makes the expression inside the absolute value symbols 0. So 4 is the x-coordinate of my vertex, and then it's 4, 1. Because I've shifted this 4 units to the right and a vertical shift 1 unit up. Right, so that was a little quick talk about shifting left, right, up, and down. But there's also another type of transformation called a stretch. Here we have the absolute value, or f of x equals 3 times the absolute value of x. So f of -2 is 3 times the absolute value of -2. That's 3 times 2, or 6. F of -1 is 3 times the absolute value of -1. 3 times 1 is 3. And then we complete our table of values, and we graph our points. And we see that there was no shift from the origin. My vertex is still at 0, 0. However, this particular function is it's more narrow than the original parent function, because in fact the pieces of the function are 3 times as steep as the original function. So when something is 3 times as steep, it's going to be more narrow. That's my vertex, and I can see my vertex there in the equation. So last one, f of x equals -4 times the absolute value of x. This is the first time I'm seeing a negative sign out in front of the absolute value. So we'll wonder what that does to our function. F of -2 equals -4 times the absolute value of -2. That's -4 times 2, which is -8. F of -1 is -4 times the absolute value of -1. That's -4 times 1, or -4. And I continue like this in my table using mental math, and I plot my points, and I connect my dots, and I can see my vertex is still at 0, 0, so there hasn't been a horizontal or vertical shift. But this particular curve is actually 4 times as steep as the parent function, and it is reflected down because of that -4 in front of the absolute value expression. So it is a reflection and a compression of the parent function. The function slopes are negative 4 times those of the parent function slopes. So that was a little bit on the absolute value function.